I'm speaking to you today from Naarm, which is the Wurundjeri name for Melbourne, Australia. And I start this meeting by acknowledging the Wurundjeri people of the Kulin Nations and their continuing connection to land, waters, and culture. Sovereignty was never ceded. I pay my respects to the elders of the Kulin Nations, past and present, and I extend this respect to any Aboriginal and Torres Strait Islander elders who are joining us today. So welcome everybody. If I've not yet met you, my name's Felicity McCormack, and I'm the co-chair of the Joint Commission on Ice-Ocean Interactions. So this is a joint commission of IACS, the International Association of Cryospheric Sciences, and IAPSO, the International Association for the Physical Sciences of the Oceans, both of which are IUGG associations. I welcome you all to our first workshop on ice-ocean interactions. I'm very excited about the program that we've lined up over the next few days. In a moment, I'll hand over to Dr. Sue Cook, who will give us an overview of the workshop and how it's going to run. But first, I'll speak a little bit about the scientific background for why we're here and what we hope to, or what we aim to achieve as a joint commission. So the latest IPCC assessment report found that at sustained warming levels between 2 and 3 degrees Celsius, there's evidence to suggest that the Greenland and West Antarctic ice sheets will be lost almost completely and irreversibly over thousands of years. However, just over a year after the IPCC 6th assessment report was published, there was a more recent paper by McKay et al. In 2022 in September in the journal which showed collapse of the Antarctic ice threshold by the next decade. And the time thousands of years. However, that time scale gets shorter the greater the temperature threshold is exceeded. Now, we're already seeing increasing contributions of mass loss from the Greenland ice sheet to global sea level rise. And there's evidence for unstable retreat of glaciers in West Antarctica, including Waite's Glacier, which is often in the news. So due to anthropogenic greenhouse gas emissions, we're confronted with scenarios of large-scale future ice mass loss. And of significant concern is the consequent sea level rise. Hopefully you can all hear me. I think my video just stopped. Am I back on? All good, great.
Yeah, we've got you back.
Cool, okay. If we drill down now into the projections of sea level rise, we'll see that the figure on the left here shows the timing of when global mean sea level thresholds of 0.5, 1, 1.5 and 2 meters are exceeded based on the SSP 2.6 scenario that would see warming limited to 2 degrees Celsius, and the SSP 8.5 scenario, which is the business as usual scenario. So we see that global mean sea level rise is likely to exceed 0.5 meter between about 2080 and 2170 under SSP 2.6, and between 2070 and 2090 under SSP 8.5. And the global mean sea level is likely to exceed 1 meter by as early as 2150 under SSP 2.6, but between about 2100 and 2150 under SSP 8.5. If we look further to the future, over the next 2,000 years, we could see 2 to 6 meters of global mean sea level rise under 2 degrees of warming. We would see 12 to 16 meters of global mean sea level rise under 4 degrees of warming, and models would indicate the near complete loss of Greenland and West Antarctic ice sheets in this scenario. And under 5 degrees of warming, we could see between 19 and 22 meters. And you notice that the uncertainties associated with these projections tend to increase the further out we look, and for those warmer scenarios. And that's largely due to unknowns in processes of ice mass loss associated with retreat in Antarctica. Now, ice-ocean interactions are really at the heart of ice mass loss, particularly from Antarctica, and to a lesser extent in Greenland, where atmospheric processes are also dominate. So if we look at Antarctica in the figure from Colleoni et al. On the left, The ocean really is driving the ice mass loss, particularly in West Antarctica, where we see melting and thinning of ice shelves, which reduces the buttressing force applied upstream on the glaciers, leading to acceleration of ice into the ocean, sea level rise, and grounding line retreat. If the grounding line's resting on a bed that slopes downwards into the interior of a marine basin, so that's a sector of the ice sheet that's grounded below sea level, then we can see instabilities arise. In Greenland, it's a little bit different. So we see subglacial discharge at the grounding line, which leads to buoyant plumes that melt the ice at the terminus of the glacier. And this recent paper by Slater et al. Found that melting is driven both by the warming ocean, but also with strong forcing by the atmosphere, by turbulent processes that flux heat from the ocean into the ice. If we zoom out to a broader scale now, the freshwater input into the ocean from ice shelf melt, from glacial melt, and from melting of icebergs impacts ocean dynamics and sea level rise. And climate change is also impacting the heat supply from the ocean. So where that heat is making it to melt the ice, and the distribution of that in time as well. So some of the key challenges then are developing theory that we can use in ice sheet and ocean models to predict how levels will rise as ice continues to melt. So what are the processes driving melt? How do they vary for different ice-ocean systems? So, for example, warm or cold cavity regimes in Antarctica, convective or diffusive ocean regimes. And we'll hear a little bit more about that in session 1 of the workshop. Another question is, how do we validate theory? By using observations so that we can better represent these processes in everything from the fine-scale ocean models to large-scale ice sheet models that run on timescales of millennia. Another challenge is observing and modelling ice-ocean interactions. What do we know about melting at tidewater glaciers? How well do our ocean models represent ice shelf melting? And we'll hear about that in session 2 of the workshop. How do we best observe ocean processes that lead to melt at the ice-ocean interface? And at what temporal and spatial scales do we need to observe them? Another challenge is in, that's covered. Another challenge is in designing observational networks to improve process-based understanding. So how do we, where and at what scales do we need to measure? We'll talk about that in session number 3. And then what do our models tell us about future sea level rise, and where are the uncertainties? And that will be covered in session 4. A third challenge is reconciling theory, observations, and models. And this is a particular challenge given the broad range of temporal and spatial scales that we're considering for ice-ocean interactions. How do we best reconcile theory, observation, and models of melt at the ice-ocean interface? And what are some current initiatives that are working towards answering that? And we'll hear about this more in the linkages session 5. So a bit about JCIOI, or the Joint Commission on Ice-Ocean Interactions now. The Joint Commission was established in January 2021. And focus areas are under ice shelves, at the ice ocean front in tidewater glaciers, and at the sea surface in the marginal ice zone in Antarctica and Greenland. We aim to complement the activities of existing groups, so FRIS, PSUS, SCARS Instant, GRISO, MISO-MIP, activities of the WCRP and other initiatives. And again, we'll hear a little bit more about that in our linkages session. But our aims are really about addressing unknowns in ice-ocean interactions, and we aim to do this through facilitating knowledge exchange at meetings such as this workshop, and then through that having a community-driven way of articulating those knowledge gaps. We aim to build connectivity and collaboration by providing opportunities to develop linkages between researchers, groups, and initiatives. We want to make sure that this science is accessible, and that it's accessible not just to people within our own discipline and perhaps kind of early career or PhD students within our own disciplines, but also across disciplines, so that we have the most impact in communicating our research around ice-ocean interactions. And another aim around that is, I guess, providing resources to help boost the profile or recognise the importance of these kinds of research. So who we are, this is an overview of the Executive Committee. So along with Dr. Isabel Nias from the University of Liverpool, I'm co-chair of the Joint Commission. We have Associate Professor Yoshihiro Nakayama from Hokkaido University and Dr. Donald Slater from the University of Edinburgh, who are the co-vice chairs. Dr. Sue Cook, who will be speaking in this session as well, is from the University of Tasmania and is our secretary. And then Assistant Professor Hélène Zarussi from Dartmouth College and Dr. Sushil Adusamili from the University of California, San Diego are also on the executive committee. Just wanted to give a quick plug to our session at IUGG in Berlin in July next year. So this session will be on ice-ocean interactions and is jointly convened by members of IAPSO, IACS, through the Joint Commission on Ice-Ocean Interactions, and also IASPI. Abstract submissions are now open and they close in mid-February. So if you're working in this space and would like the opportunity to present your research, I'd really encourage you to submit an abstract to that session. And then finally, I just wanted to plug our website. So Sue has put this together, and there's lots of information about who we are. We'll put all of the recordings from this workshop up on the website, or links to the YouTube of the recordings on our website. We publish information about upcoming events in our calendar, and we also have a Twitter account which you can follow, and we'll be posting those kinds of information. Please do feel free to email us about anything to do with the workshop or initiatives more generally. I've popped our email up on that slide there.